So this is the first in a series of videos that I'm going to make that just walk you through a couple of different techniques that you're going to have to know how to do and that you've mastered or that you need to master for the final exam, for the ACS final exam for General Chemistry 1. The first topic that I want to talk about is dimensional analysis. And I've got a total of 10 practice problems that we're going to walk through. And this is a technique, or this is a skill that you need to have that will permeate through the entire exam. So you're going to see multiple choice questions. However, this right here is a conversion that you're probably going to have to know, or be able to do something like this. So 5,400 inches converted into miles. So what we need to do is find those connections. So one thing that you know is that 12 inches equals 1 foot. But what is the connection between feet and miles? Is there a direct connection? And yes, there is. 5,280 feet is 1 mile. So to set this up, what you want to do is you want to start with what you know, or what you've been provided with, and that is 5,400 inches. Then 12 inches is 1 foot. And then 5,280 feet is 1 mile. Once you have this, you can plug that into your calculator. So what you will do is multiply across the top and divide by the bottom. So when I plug that into my calculator, that's 5,400 times 1 times 1, so 5,400 divided by 12 times 5,280. And the answer that I come up with for that is 0.08522272727. Now, to provide the best answer for this, you have to be familiar with significant figures. And when we look at our number up here, 5,400, that gives us our definition of the number of significant figures that we have to work with. 5400. Please note that this is not the same as 5400 point, because this decimal point gives you some precision. So what we have here is two significant figures. So our answer should have two significant figures. Well, 85. So what you can do is you can write 8.5 times 10 to the minus, how many places did we move our decimal? 2 miles. That is our final answer for this question. So 5,400 inches is the same as 8.5 times 10 to the minus 2 miles. So here's another example of a conversion. In this case, what we're doing is we're going from a large quantity to a small quantity. We want to express 16 weeks in seconds. So this is going to be several steps. So 1 week, as we all know, equals 7 days. 1 day equals 24 hours. 1 hour equals 60 minutes. And finally, 1 minute equals 60 seconds. So there are different ways that you can look at this. For instance, you could combine these two and say that, well, 1 hour is 60 times 60, so 1 hour is 3,600 seconds. And as long as you do the conversion properly, when you set up your dimensional analysis, it will make no difference. Okay, so we're starting with 16 weeks. We want to go weeks to days, so 1 week is 7 days. 1 day is 24 hours. 1 hour is 60 minutes. And 1 minute is 60 seconds. So when you plug all of this in, what you're going to do is say, calculator, 16 times 7 times 24 times 60 times 60. All of that divided by 1s equals 9,676,800 seconds. I forgot a 0. Sorry about that. Okay, now we have to consider the number of significant figures that we have to work with. And so ultimately, our answer started with 16 weeks, or our problem started with 16 weeks, which shows 2 significant figures. So we have to take this number and convert it into 2 significant figures. And we have to express this in terms of scientific notation. I think the best way to do that is to take our 2 first numbers, 9, and round that up to 0.7 times, in this scientific notation, how many places are we moving the decimal place? 1, 2, 3, 4, 5, 6. 9.7 times 10 to the 6th seconds. So 16 weeks is equal to 9.7 times 10 to the 6th seconds. Here we have a conversion where we are going from US custom units to the metric system, 54 yards. So we have yards. The way that I'm going to do it is 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. 1 inch equals 2.54 centimeters, and 1 centimeter is equal to 10 millimeters. So I'm going to do it like that. 1 yard is 3 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. 1 centimeter is 10 millimeters. Okay, plug all that in. 54 times 3 times 12 times 2.54 times 10. Divide that by 1, and you get 49,377.6 millimeters. Again, we got to go with sig figs. There are 2 sig figs, so 4.9 times 10 to the 1, 2, 3, 4 times 10 to the 4th millimeters. As has been the case throughout this, throughout all these practice problems, the way that I do it is not the way that you have to do it. For instance, you could change your definition and say, well, 1 inch is equal to 25.4 millimeters. That wraps up both of these conversions into one quick step, so it saves you a little bit of time there. So this step right here, this is a little bit more involved because this is a multi-dimensional conversion. We have 36 centimeters per second, and we want it converted into miles per hour. So we have 2 dimensions that we're going to worry about, and the first dimension is I'm going to go with the distance. So what I'm going to do is say 2.54 centimeters is equal to 1 inch. 12 inches is 1 foot, and 5,280 feet is 1 mile. The other dimension that we have to be concerned with is time. So 60 seconds is 1 minute. 60 minutes is 1 hour. So the way that we can set this up in a simple dimensional analysis problem is write 36 centimeters per second. And what we're going to do is consolidate all of these conversions into one line. So the first thing that we're going to do is we're going to deal with only our top dimension, our centimeters. So 2.54 centimeters is 1 inch, and 12 inches is 1 foot. 5280 feet is 1 mile. And now, technically, I'm done with the top dimension, but this is a 2-dimension problem, so we're going to take the other dimension at this point. And so we're going to say 60 seconds is 1 minute. Because what we want to do is the units that were in the denominator, we want to put in the numerator. So our second dimension is seconds. We have to put that in our numerator up here. And so if we solve the problem at this point in time, our answer would be miles per minute. But that's not what we want. We want miles per hour. So we have to take this another step. 60 minutes, 1 hour. And now we're ready to solve. So 36 times 60 times 60 divided by 2.54 times 12 times 5280, close parentheses. All right. And this gives us 0.80529, and it goes on from there. And our units are going to be, well, miles, or mph. I'm just going to say mph. Again, 2 sig figs. We need to only have 2 sig figs. So I'm going to write this in scientific notation as well as, or with the correct scientific notation and with the correct number of sig figs. I'm going to move my decimal place back 1 time, so 8.1. I've rounded from 0 to 0.1, or from 0 to 1 because of the 5 that follows it. That is times 10 to the minus 1 mph. Okay. And there is our answer.
This right here is a 2-dimensional conversion with some units that you might not necessarily encounter very much. Grams to pounds, that's something, though, that you should be relatively familiar with. 454 grams is 1 pound. Milliliters to gallons, however, is a little bit different. There are 3,785 milliliters in 1 gallon. Okay. Now, in order to solve this problem, what you need to do is just start out with 1.09 grams per milliliter. We're going to take our gram dimension, our mass dimension, and convert that. So 1.09 grams, 454 grams is 1 lbs. Lo and behold, once we've done that, grams are taken care of and we're left with pounds. So if we solve this right now, our answer would be written in pounds per milliliter, but that's not what we want. So now we have to take care of our second definition. Our second definition is 3785 grams. I'm sorry, not grams. 3785 milliliters in 1 gallon. Okay, so the units that we'll cancel out are milliliters, milliliters. Once you cancel all the units out, you're left with pounds per gallon. So 1.09 times 3785 divided by 454 gives you an answer of 9.09. I just rounded that up from 9.08733, which we wanted 3 significant figures, 1, 2, 3 sig figs, Our units are pounds per gallon. And that's all there is to this problem. This conversion is not too hard either. It's 19 inches converted into feet. Well, we know that or 1 foot is equal to 12 inches. So we want to set up 19 inches. 12 inches is 1 foot. There we go. So 19 divided by 12 equals 1.5833. If you're confronted with a problem like this, one of the things that will certainly be to your advantage is to remember significant figures. Our number started with 19 inches, has 2 significant figures. Well, we need 2 significant figures in our answer, so 1.6. I took that 1.58 and I rounded it up to 1.6, so 1.6 feet. Oopsies. Well, I'm just going to put a box around that. 1.6 feet. There we go. And that's all there is. Another fairly direct conversion, 840 inches to centimeters. Well, 2.54 centimeters is equal to 1 inch. Okay, so we can simply present that 840 inches, 1 inch in the denominator, 2.54 centimeters in the numerator. I'm going to erase part of this out, and then draw that line back in. So our answer is going to be 840 times 2.54 equals 2133.6 centimeters. Again, significant figures. We have 3 to work with. Our answer should have 3. So I'm going to call that, well, these 3 sig figs are what I care about. I use scientific notation to rewrite this number as 2.13 times 10 to the 123 to the third centimeters. 3-dimensional conversion, grams to pounds and centimeters to feet. So 454 grams is 1 lbs, and 2.54 centimeters is equal to 1 inch. 12 inches is equal to 1 foot. So we have several steps here. 4.22 grams per centimeter. 454 grams, 1 pound. Our units will cancel, grams, grams. We're left with pounds. So if we finished at this point, it would be pounds per centimeter. But that's not what we want. We want pounds per foot. So we're going to go on, and this is kind of the second part of our conversion, centimeters. We've got to put centimeters in the numerator. 2.54 centimeters is 1 inch. 12 inches is 1 foot. And we're done. Inches will cancel, centimeters will cancel. Sorry, inches will cancel. So now we're left with the only units that we're left with are pounds per foot. So we multiply this all out, multiply by the top, and multiply the top out, divide by the bottom. So 4.22 times 2.54 times 12 equals, divided by 454. The answer that we come up with there is 0.283316. Obviously, we don't need that many numbers. Instead, we only need 3 because our starting number was 4.22, which has 3 significant figures. Our answer, therefore, needs 3 significant figures. So I'm going to only use this 283, but I'm going to use scientific notation to say 2.83 times 10 to the minus 1. What are my units? Pounds per foot. And that will be the end of that problem. So with this problem, I want to show you that you can solve these problems in a number of different ways. We have two dimensions here, feet per second. And we need that converted to meters per minute. Now our lower dimension is fairly simple. 60 seconds equals 1 minute. The upper dimension is a little bit trickier for me. What I'm going to do is I'm going to define 1 foot to be 12 inches. 1 inch equals 2.54 centimeters. Now this conversion right here, inches to centimeters, is my way of getting into the metric system. Now 100 centimeters is equal to 1 meter. So if I use all of this, I'm able to get to where I need to be, but it's a little bit roundabout way of doing it. So 32 feet per second. I'm going to take care of my time dimension first. 60 seconds is 1 minute. So seconds will cancel. If I solve this problem right now, my answer would be with the units feet per minute. It's not what I want. What I want is meters per minute. Okay, so my time dimension though is taken care of. So I'm going to put a check mark, done. Now my other dimension is a little bit trickier. I have feet, so I need feet in the denominator. What's my relationship there? 1 foot is 12 inches. 1 inch is 2.54 centimeters. 100 centimeters is 1 meter. So what units do I have? I have feet and feet, those will cancel. Inches and inches, those will cancel. Centimeters, centimeters. And I'm left with meters. I'm going to go ahead and write in the word meters. So whenever I plug all this in, what I get is 32 times 60 times 12 times 2.54. And I'm going to divide that by 100. And my answer for that is 585.216. 3 sig figs is what I'm left with, so I'm going to use those as, 2 sig figs is what I need to have, so I'm going to use those as my 2 sig figs. So that means I need to go 5.85 and round that up to 5.9 times 10, and I move my decimal place 2 positions, and I'm moving it to the left, so it's positive. 5.9 times 10 to the second meters per minute. So that's really all that there is to this. The entire process of dimensional analysis is simply a matter of figuring out what your relationships are, how you get from one unit to the next. If there are 2 dimensions, well then you have 2 different things that you need to be concerned with. But all things considered, this is a process that just requires a good bit of practice. Good luck.